That sounds like an excellent idea, Sammy.
Oh, no, I know. We're gonna have so many bad puns in this episode. Our friend Norman would be so proud. Hello, everyone, and welcome to Winging It with Frank and Sammy. It's been a hot minute since we've recorded an episode. Apologies for that. But I am Sammy, and this is my co-host, Frank. Frank, how have you been since the last time we recorded a podcast?
I'm trying to remember when we did record the last podcast. It seems like a lot has happened since then. We had the dinner.
It
That
was
was
like a
kind of
month
cool.
ago.
It was about a month ago. Okay, we're a little behind schedule, but I'm ready. Let's do it. Here we go.
All right. Yeah. And Frank is a little under the weather, so apologies if we have some coughing in here.
Yeah, sorry. Almost better.
We're recording this on Saturday, April 4th. I'm going to try to turn this episode around for tomorrow, which is Easter, because this episode is all going to be about eggs, which is appropriate given the time of year and also, like I said, Easter tomorrow. So this episode was a bit delayed because we're trying to get a guest on. We are not experts in eggs. We have been doing some research for this podcast. But it didn't work out with the guest, so that's kind of why the episode was delayed. But we're going to walk you through a little bit about some of the strategies birds use for laying eggs and also some of the anatomy and physiology of how eggs are created within the female bird body, and even then the anatomy of the egg and the eggshell itself. But where do you want to start first, Frank? I know you said you had a lot of fun facts you discovered researching this.
I'm just always excited to learn new things about birds. And for some reason, I just never really delved into eggs and why they are what they are. Like I knew the basics, like they're speckled so that they can be camouflaged and things like that. But beyond that, I was just like, yeah, it's an egg. I don't, it's fine. I'm more interested in the nesting and the behavior and the migration and stuff. But yeah, I did a little digging into why eggs are the way they are. And I guess I shouldn't be surprised at this point, but it's actually really fascinating some of the adaptations that they have and some of the different things that they do that I just never even thought about. And so I really appreciate that. I appreciate that this podcast made me learn stuff. So as for where to start, I just kind of like to think, and I like to start at the surface. Like when you see an egg, right? It's size, shape, color pattern. It's not that dissimilar from birds, except the behavior is pretty and it just sits there, right? It doesn't do anything. So size, shape, and color pattern. Um, I I think it's fascinating to me that there are so many variations in sizes. Like you got the giant ostrich egg, a tiny little
Hmm.
hummingbird egg, and all sizes and shapes in between. And again, I shouldn't be surprised because there's so many different shaped birds and they do so many different things. It should make sense. But it was just like every time I met a new thing, I was like, oh, this is so cool. I'm like, sharing it with people. Like, check this out. So kind of neat. One thing that kind of makes sense on the surface, and I imagine you'll touch on something similar to this when you talk about the anatomy, is the size and shape of the bird itself will actually influence the size and shape of the egg it can produce, right? So if it's like a narrow bird, it's not going to be like a giant fat round egg. There's some physical limitations in there, which pretty straightforward. You're not going to see a hummingbird sitting on an ostrich egg anytime soon. Let's see something else I learned, right? We know we talked about in the nesting, we have the cavity nesters, and then we have the ones that nest in like the cups and the ground and things like that. The cavity nesters tend to have pale eggs. They tend to be white or very off whitish. And the reason for that is so that they could see them in the dark.
Yep.
Blew my mind. It's like, that's amazing. Didn't ever question it or think about it.
Yeah, no, but
Anyway,
it's interesting with the yeah. So my oak titmice nest box, they got 7 eggs in there right now, and
so,
yeah, in the camera you can see they're all bright white. And yeah, they
mhm.
stand out. They're like there's hardly any pigmentation on them whatsoever. And yeah, again, they're cavity nesters.
Yeah, yeah. So I get people who come in the store and they'll be like, "Oh, I saw this egg, and sometimes they have the egg, and sometimes they have a picture of it. Like, can you identify what bird this is? And I would just be like, I have no idea. Like, it's not a chicken, it's not a hummingbird, it's not an ostrich. Those are like the three shapes I can identify, right? Anything other than that could be anything. So now I feel like I can actually narrow it down a little bit. It's like, okay, well, it's a cavity nester, so that's going to narrow it down. And like, you'd look at the shape a little bit. And I'm excited to like try it now. I kind of want somebody to the next time, like probably the next couple of weeks, somebody will have egg pictures or something, and that'll be kind of fun. The other thing I learned about the shape, right? So they can be round, because they're more structurally intact. I'm blanking on the word. So stronger. If they're the more round they are, the stronger they are. The more they kind of elongate, the more delicate they become. So you get
Or
eggs that
structural
are
integrity.
the integrity. There we go. I watch enough Star Trek. I should be able to know that off the top of my head. You get some of these eggs that kind of come to a point at the end. It's kind of like a killdeer. Like I've seen a lot of killdeer eggs, and they're kind of always in that circle, right? I never thought about it again, but that's so that they don't roll away. And I'm just like, that's genius. I didn't even think like, oh, a round egg. It would just keep going. They nest on the ground. They have hardly a nest at all. It's like a divot. They're always running around doing the wing thing. It could easily happen that it just rolls away from the nest, right? So they have that point on one end. So when they roll, they just roll around in a circle. That works for the cliff nesting birds, the murres and things like that. That's pretty genius. And it started me thinking like, what came first? The nesting on the cliff or the shape of the egg so that it could nest on the cliff and the whole species didn't just like all the eggs rolled off the cliff kind of a thing. So it's really kind of still had a little bit of a fever when I was doing this. So I went into some rabbit holes with like really thinking like, how does this work? What came first? It's okay though. It's fine. That was really fascinating to me to find that that point actually served a purpose that preserves the egg, which is cool.
Yeah, it's interesting to see. I've been doing some surveys of people's backyards around here, and I found a couple of killdeer nests on people's just like their gravel driveway. And yeah, you
Hmm.
can see that kind of that shape, and it's like there was one nest that had 3 eggs, and the narrow end is all pointed kind of in the middle.
Yep.
So, and
Yeah.
yeah, but it's just this little divot in the gravel, and yeah, so if, parent gets up, walks away, the eggs aren't gonna be rolling out of the divot. What I thought was really interesting was just how well camouflaged they were,
Hmm.
because we saw the killdeer and we're like, "Oh, she probably has a nest around. She's acting a little bit, kind of, distressed." And so we were looking and, really, I can't believe we didn't step on the nest or step on the eggs because they are so well camouflaged. I mean, they look just like the gravel, essentially. I mean, if you weren't looking, you could, you would step right on them.
Yeah. I imagine that happens, unfortunately. Um, I always think of the snowy plover nests out here on the beaches that, we have to go put cages around and everything. There's so many times where I see the snowy plovers and don't see the eggs, like sit there with the scope and go back and forth and back and forth. And it's like you're looking for that one twig out of place or the tiny rock that might be there. And then it just looks like a bump in the sand. It's amazing how well camouflaged they are. It's just it's amazing how that has come to be that they've been able to develop these incredibly well camouflaged eggs. I mean, not all of them are, right? If you think of a robin, the baby blue robin egg, not really camouflaged. Like that doesn't serve any purpose for camouflage. It's in a brown nest, so they just have to hide the nest a little better. So it's interesting that some species will go with the camouflage egg and some will do, the visibility, I guess, that they're going for. So,
Yeah, and I was reading that birds only have like 2 pigments they produce. Basically, one's called biliverdin, which is kind of that bluish green color we're talking about, and
hmm,
another one is protoporphyrin, yeah, which is kind of the reddish brown. And so basically the mixture of those 2 is how you get the different kind of color of eggs. So it makes sense. You don't really see, like,
wow.
even if you think about chicken eggs, yeah, you can see white, which would be like a lack of pigment, or that kind of brownish, golden brown,
Right.
reddish brown, or that kind of bluish green. And
That's interesting. So they have a palette of two colors that they can use. So how does the camouflage develop on the egg like that. I would think with the two, it would have to be like a solid color either way, but they could somehow it can do patches of color and
Yeah,
not color
and
in an
so
eggshell.
yeah, my advisor in grad school, she actually was like did her PhD on like egg patterns. But the inside when the shell is formed, like in there's a shell gland, and the inside basically the egg rotates, and they can like put little kind of blotches of pigment as the egg is rotating inside the shell gland. So it's not all just one solid color.
That's so it's like a decorating factory going on in there.
Yeah, yeah,
Huh.
and I remember I was reading, one of Jennifer Ackerman's books about, the bird way and talking about how, I think we talked about this last time with hosts birds that have, nest parasites like cowbirds and
Mhm.
cuckoos and all their host species. The host birds will try to develop these intricate patterns that then the parasite species will try to copy so that, there's this kind of a continual race to create a new pattern. The cuckoos and the cowbirds try to copy that new pattern. And, it kind of just keeps going, try to keep getting more intricate patterns or different patterns so that the host can detect the egg and reject it. And then, of course, the parasite species don't want the eggs to be rejected. So they're trying always to mimic the
Wow,
patterns.
it is wild because it seems like that would have to be a conscious thing. Like it would have to be something the birds are actively studying the eggs that they're trying to imitate, and it's insane because it's not. I would imagine can't. They don't have like the control over the pattern, right? Like
Yeah, I
actual
don't,
conscious.
I don't know the psychology of that. I wouldn't think there's much voluntary control. I think it would be more of like a generational thing that,
Right.
like, over time, right, cuckoos or cowbirds that were better at imitating the eggs, right, they would get their eggs rejected less often, and so that pattern would continue on. And
Yeah.
then bird host species who are able to discriminate better or have more intricate patterns that couldn't be replicated, those would, be more advantageous, and so it's kind of this evolutionary arms race.
So this is like over many, many years. This isn't like the same birds going back and forth every year.
I
Like this
don't
year, I'm
think
going to add a
so, yeah.
stripe.
Yeah, 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 but
That
I
would be
don't it
funny.
could be, I don't I haven't looked into that enough.
Nah, that's pretty neat.
But I think you should talk about why birds lay eggs in the first place. For one, it's, most birds fly, right? And so instead of carrying your young like mammals do, it's gonna be a lot more advantageous to deposit your young somewhere else so you don't have that extra weight, flying around with you. That's gonna be a lot of hard work.
Yeah.
I like to, I get into like the anatomy and the evolutionary history of this all. Birds are dinosaurs and they're essentially reptiles, but mammals and reptiles, we are what we call amniotes. So basically, the difference between us and birds and reptiles is we just keep our egg inside. We don't lay eggs outside. We just have it inside. But essentially, without, take away the shell and all the interior structures are more or less the same. So, we mammals have an amniotic fluid, an amniotic sac. Same thing for birds and reptiles. They have an amniotic sac where the embryo develops. And again,
Hmm.
basically, instead of a yolk, well, we do have a yolk, but we have the placenta as the main way to nourish and take nutrients. And eggs obviously don't have a placenta, but they just have other structures that accomplish the same thing. So I always think that's interesting how you can have these different groups of animals essentially have, in my mind, the same strategy. Just one is external and one is
Mhm.
internal. And then that external strategy for the birds is also really helpful because then they can fly.
That is very interesting. I don't know that I'm going to be able to eat eggs anymore after that now, but nice. I think that's good to know. Um, since it's nesting season and we're talking about eggs and we just talked about nests, I feel like we should include like a PSA in here about what people should do if they find an egg on the ground or a baby bird on the ground or a nest that's blown out of a tree after we just had like
Good
60
idea.
mile an hour winds here. Um, what I tell people at my store, and I've talked to the rehabbers and everything, if you find a nest on the ground, if you know where the nest came from, you could try and put it back up there. If there's eggs that fell out of it and broke, obviously can't do much about it. But if you do put the nest back, the birds may come back and try another clutch of eggs. If you see the nest and you find a nestling or an egg or something on the ground nearby, if you can put it back up there, that's fine. I know there's that old wives' tale. If you touch a baby bird, if you touch an egg, the parents will abandon it because they smell your human grossness or something. That's not actually true. I don't know where that came from. So if you can get it back in the nest, great. If you can't get it back in the nest, you can take and make a fake nest and put it
Oh,
somewhere nearby, like out of harm's way if it's a nestling. Because the baby bird will call for the parents. Parents will hear it and might actually adopt the nest and just move in and do that there. So that is a possibility too. Failing all of that, you can contact a wildlife rehabber. Just know that they get a million calls this time of year and they're very busy, so they may not be able to come and get it. So you want to try and solve it yourself as best you can while being safe with the birds and everything like that. That's my PSA for when you find a nestling out there.
yeah, that's a good reminder to everybody because there are going to be a lot of times where you think the bird is abandoned, but the parents are right nearby. I
Yeah.
remember last year, Jess told me she works at an elementary school, and she found a baby starling, and she rescued it because it was getting attacked by a scrub jay.
Oh,
But so she kept it around till the scrub jay left and then released it back, and the parents were right there the whole time and they took care of it. So
yeah.
even if a baby looks helpless, the parents may still be around and may still be able to feed it. So, but I would say, yeah,
Yeah.
if you can put it back, put it back. If it does, I would only take it out of the situation if it seems like it's obviously in harm's way, like there's some
Right.
predator or something bothering it, and immediately.
Yeah. Yeah. I guess I should have been more specific. Nestling would be when they're mostly still bald. They don't have a lot of
Mhm.
feathers. They don't have the primary feathers, the flight feathers in yet. When they get to the fledgling and they've left the nest, mostly voluntarily, they're going to have more feather coverage. They're going to have some of the flight feathers in. They're going to eyes will be open. They'll be alert. Those are the ones that you can usually just leave alone. Like Sammy said, take them out of harm's way. But generally, the parents will still feed them while they're learning to navigate being birds outside of the nest. Like young robins, every year, there's always people that call about the young robins. I found a few. They're just like grumpy little old men, and the parents will still come and feed them. So
I
most of the
know they
time,
do. They're
everything
all
is,
kinda
is
like
fine.
half bald. Yeah, they're so funny.
Yeah, yeah. This, I guess we should also say this is a great time if you have outdoor cats to keep the cats inside for just a couple months so that these fledglings that
Mhm.
are running around on the ground have a chance. They're very easily caught by cats. So it's very sad. But if you can keep your cats indoors for the next several months or all the time, that would be great.
Well, any other fun facts you discovered, Frank, that you wanna share in your excellent research?
Uh, I do get a lot of questions about incubation periods. Like people want to know
Hmm,
how long do they
that's
sit
good.
on the nest for these eggs? And it's kind of correlated to the size of the bird because usually bigger birds, bigger eggs take longer to mature and develop. So your songbirds, your hummingbirds tend to be the faster ones that are just like 3 weeks ish for the eggs to hatch. There's also what's the word? Precocial, and what's the other one? Begins with an A.
Electrical.
Right. The one where they come out and they're bald and eyes are closed tend to hatch faster than the ones that have to develop more in the egg and basically hatch and run. So that's like a thing that factors into how long the incubation periods are.
So, I got my oak titmouse, right? And I was reading up on their, stats. A good resource for people who want is called Birds of the World. It's by Cornell, same group that does eBird and All About Birds. You do have to pay. It's about $40 a year, so it's really not that expensive. But it has all this kind of life history information and great detail for tons of different species. Well, for pretty much every species. So for oak titmouse, the incubation period is about 14 to 16 days. And then generally, whatever the incubation period is going to be roughly the same for birds that stay in the nest. That's gonna be roughly the same for how long it takes before after they hatch till they leave the nest. So the oak tip mice, for example, they just laid their eggs. They just finished a couple days ago. So their incubation period is about 2 weeks. So they're going to hatch mid-April. So
Yeah.
maybe in a week and a half or so. And then from hatching to fledgling, there is a be about another 2.5 weeks. So the kind of whole
Okay.
process is about a month or so. But something like a red-tailed hawk, one of the most common hawk species around, their incubation period is going to pretty much be a month. And then the nestlings are going to take about a month or maybe 5 weeks or so till they can start to fledge and leave the nest. So,
Okay.
like Frank said, whatever the size of the bird is, that's gonna be
Right.
corresponding to their incubation period.
Like some of the big ones, like, ostriches and stuff, it gets to like 80 or 90 days. So it's significant investment to protect that.
Let me look what a condor nest period is.
Feels like it takes forever on those webcams. Just keep watching. It's like, and then how long it takes them to fledge. I mean, they're so big.
Yeah, condor incubation period, 53 to 60 days.
Yeah. That's
So,
just for
yeah.
incubation.
So the nestling period, 163 to 180 days. So it's like, whoa, that's like 3 times as long as the incubation. That's crazy.
Yeah.
Wow, so that's
That's
okay.
a lot of investment.
Yeah.
I like thinking of all these warblers, right, that are migrating north right now. And they have this limited window to go up, find a territory, build a nest, lay the eggs, incubate the eggs, get the fledglings out of the nest, and then migrate back before winter comes back. It's like it makes me anxious. A little too tight that window. Man,
That's your empathy. You can feel their reproductive,
right?
anxiety in some
But
ways.
I mean, it's a lot. It is a lot. Yeah.
Oh man, that's too good. Well, yeah, another thing I wanted to talk about, because I was just kind of
So,
curious about this for myself, and I think other people are curious, is like, how do eggs actually form, right? But if you think about a bird's reproductive tract, so they have the ovaries, just like mammals, those release the egg or the ovum. And then the sperm from the male is going to fertilize that up in the oviduct. So very similar to humans. So after that, after the sperm gets fertilized or the egg gets fertilized, then that's kind of when the whole egg process actually starts to kind of form. So it first starts with you have like the actual cell that's been, fertilized, but then you start forming the yolk. This is kind of happening as it's going, starting from the ovaries, and the egg is sort of traveling down through the oviduct out towards the opening, the vagina. So you have the egg and the yolk, and then you get the albumin. So the albumin is the white part of the egg. The yolk and the albumin are kind of there for like nourishment, proteins, energy, important vitamins and minerals, kind of things like that. But the albumin also kind of helps to serve as a cushion for the developing embryo. So it keeps going down, and this happens in a part of the ovary called the magnum. And then you get to the isthmus, which is where you start to get the soft shell, kind of that. If you've ever, had a hard boiled egg, right? And you like crack it outside the hard shell, you have that thin little layer around you have to peel off. You know what I mean? And then at the very end of the, what we call the uterus or the shell gland, that's where you get the hard shell. It's also where we get the pigmentation in the hard shell. And typically this takes about 24 hours. So for my oak tip mouse box, for example, she laid her first egg, I think March 24th was the date. And then basically every day in the morning, she'd be laying another egg. And so she laid 7 eggs. It took her 7 days, 24 hours per egg. And what's interesting about the shell is that it's still porous. So air can still get in. And so, right, the chick still needs to respire, take in oxygen, and exhale essentially carbon dioxide. It's not doing that through lungs, but the cells are still doing that. And so the shell is porous to air. It does have a layer around it called the cuticula, which is basically like kind of helps seal it from bacteria, so bacteria don't get in and infect it, which I thought was really interesting. But as the embryo develops, again, it uses that energy from the yolk, and it obviously gets bigger and bigger, fills up more of the egg. It like develops within the amniotic sac, just like humans do. Yeah, they just have that kind of eggshell around them That's really kind of the biggest difference. And then obviously once they're ready to hatch, then they have to break through that eggshell. But and this is a very basic surface kind of description of it. Like I said, I am not an expert, but I think that's so really interesting that I think we see eggs, and most eggs that we're probably familiar with are from chickens that aren't fertilized, and so they're not actually alive per se. So I think it's easy to think of an egg as not really an active or a living thing, but it is very much alive and growing. And yeah, it's just fascinating that this, structure is so intricate and so complicated, creating a new life. I think it's beautiful, really.
That is that is pretty amazing. I think the thing that you said in there that I'm like turning over in my head, this all happens in 24 hours, that whole process of creating the egg, right? So birds are not flying around with a bunch of eggs inside them already, right? So you said like they lay eggs so they don't have to carry that weight. And she's laying an egg every day. So at most, at one point, she has like one egg inside of her and she's flying around. So that I think is really fascinating because I have definitely heard people come up and go, "Oh, that bird looks fat. I bet she's got a bunch of eggs." And I'm like, I don't think it works like that. So now that if it's a 24-hour thing, that one is incredibly fast. And two, that makes more sense that you can do one and they're not all laid at once, right? You do one, you do another day, or every 2 days or whatever some of the larger ones are. So that actually explains a lot for me. So I'm gonna I'm gonna take that back to those people who think fat birds are full of eggs. And that's gonna be very fun conversation to have.
I'm sure some birds take longer than that, but I think there's an experience. If you like to go out fishing, you see like a really kind of gravid female, and you see like thousands or millions of eggs in her, and she looks fat, right?
Mhm.
But
Yeah.
that's not the birds. Yeah, the birds don't have all these eggs in them.
Yeah, they wouldn't be able to fly. Yeah.
Yeah, yeah. Fish don't need to worry about that, and they just kind of release their eggs all at once, and that's a much different strategy than birds in general.
Interesting. And it makes sense. And I always wondered, like, with the bald eagles we were talking about, like they lay an egg and then 2 or 3 days later they lay another egg. And then usually the older one, they start fighting and the older egg, nestling, fledgling ends up winning and becomes the only surviving one. And I was always like, well, why don't they just lay the eggs faster, like back to back? So it's even, right? But I guess you can't. You do have to manufacture the egg. You do have to create it. And for those larger birds with the larger eggs, it probably is like a 2 to 3 day window, and that's as fast as they can do it. Sure. I think a whole bunch of things just like clicked for me. So,
Yeah, part of it too is, some birds will start incubating with the first egg, and some birds will wait till all the eggs are laid till they incubate. And again, incubation is
okay.
just the process of the bird actually using its body heat to, kickstart all the processes that need to happen for the egg to develop. So,
Right.
like for the titmouse, she didn't really start incubating until like the seventh egg. And so she's like on the nest right now all the time, essentially. And in some species, it's only the female that incubates. In some species, it's both parents. And then in some species, like we talked about a couple episodes ago, the males can do the incubation and the chick rearing. So the birds basically have
Yeah.
this brood patch is basically essentially a bare spot of skin. So if you ever see like they kind of settle down, they kind of like puff out their feathers as they settle down. Basically, they're opening up the feathers to that bare skin so that the heat from their body can transfer onto the eggs. In species where only the female incubates, only the female is going to have that brood patch and the male won't have that spot at all.
Interesting. Okay. So if your titmouse has all the eggs out and the process is going, right, but the heat from the bodies accelerates it, I would assume, right? So if she's not incubating until they're all out there, they're probably all going to hatch within the same 24 or 48-hour period, maybe. I'm curious to
Yeah,
see.
yeah. And I can confirm this in about a week or so. But yeah, they
Yeah, I'm
should
looking forward to
hatch
it.
more or less, the same.
Very cool. Does the male help with the incubation there, or is it only ever one titmouse in the box at a time?
She's in the box and he feeds her. And so that's his part.
Okay, got it. That's pretty cool.
For those who have like raised chicks before, right? You have to have an incubation lamp instead of, since if you
Mhm.
don't have a mother hen. And then
Yeah.
this morning, actually, I noticed the titmouse turning over the eggs to like
Yeah.
evenly incubate them. And so like that's the same thing you have to do with chicken eggs. You got to turn them over so they're evenly cooked, essentially.
Yeah. That's interesting. Hmm. This has been a fascinating podcast. Well done.
Yes, yes. And again, we are not experts. So if anyone listening has some more information you want to share with us, please let us know. That is what I personally love about birds and birding is there's so much to learn. And for someone like myself and for Frank, we've been doing this a long time. There's still areas that, we are still learning about. And you can always dive into more and learn more. And it's really a lifelong process. So, Frank, any last things you want to say before we wrap up this episode?
I think that was it for me for exciting facts.
Excellent. All right. Well, everybody, thanks for listening. Again, if you want to support us, you can follow us on Facebook, where we have our group page there. You can follow me at my website,
Yeah.
birdingwithsammy.com. You can follow Frank at Patreon/Frank the Bird Guy. Then until next time, enjoy the birds, have some good birding, and we'll see you in a few weeks.
See you later.